Okay, so now we're looking at polynomial functions. All that a polynomial means is that it has more than one term. So for instance, if we had 5x squared, this is what's called a monomial. I guess it's still considered a polynomial, but poly means many terms. Okay, so a lot of times we'll call this a monomial. We would call this a binomial. And then another term, then this all of a sudden comes into this category of polynomial. Anything that's even more terms would also be a polynomial. Okay, so it's kind of a broad term. Okay, when you're adding polynomials and subtracting polynomials, if we have, for instance, let's say I'm adding together these polynomials. Everything is added and subtracted together. So we are able to go through and combine any like terms that we have. So we look at this and we look at what the parentheses are doing and what they're holding on to. So this parenthesis set just has this polynomial inside of it, and then we're adding this parenthesis set. So really, because of this addition, these can all be moved around however we'd like, because there is an addition sign between them. And each of these terms will just keep the sign that's in front of them. So for instance, this negative 5x will keep that. So we're going to first combine all of our x squared terms. So this would give us 7x squared. And our x terms, we have 3x minus 5x, so that gives us a negative 2x. And then we have just this plus 1 here. Okay, so pretty basic there, right? We get to add those together and combine just the like terms. Now it does change things a little bit if we take minus, let's say, 4x, and we subtract from this a negative x squared plus 3x. Okay, so now we evaluate what's going on here, and we have sets of parentheses to combine or to hold our polynomials together that we're adding or subtracting. But this subtraction sign, because it is outside of a parenthesis set, has to go in and be multiplied and distributed to both terms inside the parentheses. So now what we're working with is 6x squared minus 4x minus a negative x squared. So that will give us a plus x squared, and minus a 3x. Okay, it's very important that you distribute a negative sign. If there's ever a negative, if it's subtraction or multiplying by a negative number, it must be distributed into both terms inside the parentheses. So now we can combine our like terms. We have 6x squared, and x squared gives us 7x squared. And a negative 4x and a negative 3x will give us a negative 7x. Now we can't combine anything here because they are different terms, so that's as simple as we can get. Okay, so when we're adding and subtracting them. Now what about when we're multiplying them? So if I have 2n minus 1 and I'm multiplying it by 5n plus 3, then I make sure that I am doing my FOIL, or distributing everything and making sure that we have it multiplied correctly. Okay, so if there's two sets of parentheses, two binomials, then you do need to do the FOIL method. So you would take your 2n and multiply it by both in here. So you have 2n times 5n gives me a 10n squared. Okay, 2n times 5n is a 10n squared. 2n times 3 gives me a 6n. And then I have negative 1 times 5n gives me a negative 5n. And negative 1 times the 3. Then we combine like terms to simplify it down. So we have 10n squared. That is the only n squared term. And then we can combine our 6n minus our 5n to give us just n plus, and then minus our 3. Okay, so those, when you're multiplying, make sure you multiply it out. If there are more terms than 2, then you have to multiply everything out. So for instance, if I have 5x squared plus 2x minus 5, and I want to multiply that by 3x plus 4, this term has to be multiplied by both of these, this term has to be multiplied by both of these, and this term by both of those. So this distributive property, it extends even onto bigger problems here. I'm going to throw one of these on the assignment. We can talk about it in class and you can try it. Instead of me going through it right now, it just takes more time, which is totally fine, but just make sure that, yeah, this, and I personally actually like to take the smaller one and multiply it by everything in here, but it's all the same thing. This has to go by both of these terms multiplied. This has to be multiplied by both of these terms. And this has to be multiplied by both of those terms. And you add them all together and combine their like terms. Okay? All right, so let's go into dividing. So when you divide polynomials, first of all, you just have a basic dividing. So basic dividing works this way. So if you're dividing by a monomial, so you should have a single term that you're dividing by. It's just important, it's kind of like this says have parentheses around it. It's important that you are dividing everything by this. So you could also have it written like this, right, with this 8n over here or the 8n over here. We've talked about how you can't divide out just the 8, right? You have to actually be doing that. So I'm going to rewrite it this way because to me I like looking at it this way. But if you see divided by 8n, just know you can rewrite it this way. So we can't just take it out of the 8 because that doesn't, it eliminates the 8 before it has been able to divide out of both of these as well. So what we have to do if we'd like to eliminate that is rewrite it so that it divides each term separately. So for instance, we have our 8n to the 4th, and we can divide that by 8n separately, and then we can also take and divide the 2n cubed by 8n. So as long as we divide every term by that denominator, we can separate it out. Now what this does is it gives us an opportunity to simplify these fractions more so than we could with just leaving it all together as one. Now, I'm going to take that back. You can actually still divide it, and I'm going to show you how to do that in a second as well. So there's two ways to do it. One, you can take each of these and you can separate them out, and we can then take them and simplify each fraction separately. So for instance, with this one, the 8s can cancel, as well as this n to the 4th is the same thing as n to the 3rd times n, and the n's can cancel. So this first term is left with just n cubed. Here we've got 2 and 8 can be, 8 is the same thing as 2 times 4, so we can cancel those two 2's and we're left with just 4. This is the same thing as, so one of these n's can be left, taken out as well. So we have n squared. And hopefully if you have problems with this, go back to our simplifying fractions, because I am going pretty fast on simplifying these fractions because we had a whole other section on it. So if you need more help with simplifying fractions, you'll need to head back to that section. Here, the 16 becomes 2, this becomes a 1, and we're able to cancel out one of those n's. So we're left with 2n. So see how this becomes this simplified form. Now, depending on what you're trying to work with, this is actually the form that the answers on the sheet that I'm going to give you for homework. It gives you the answers here. What I want to show you now, though, is that you can also simplify without separating it out and keep it a little bit cleaner as a single fraction. And we've done a little bit of this, is if you find what can come across in these out of all three terms. So we look for a common factor out of all three terms, which the largest number that can divide out of all of them is 2. And the largest power that can divide out of all of them is n squared. And then what I'm going to do is I'm going to factor that out. So then I'm left with 4n squared, because 2n squared times 4n squared is 8n to the 4th. The 2n to the 3rd just becomes an n. And then here, the 16, when I pull the 2 out, becomes 8. And I pulled the n squared out, so the n is now gone. But the reason is now if I do this, I can take this 8n, which is also the same thing. I'm going to write it as 4 times 2, just because we have this 2 that can cancel with this 2. And then the n's, the squared, we can have only one n left here. So then we get n times 4n squared plus n plus 8, all divided by 4. Now, in some circumstances, this might, and it's supposed to be an 8. Oh, we took the 8n out. Okay. In some circumstances, this might be easier to work with than this. So that's why I show you that, is that we need to know that you can divide each term separately, but if you want to keep it as 1, this would be the simplified form. And if you look, then the n square, n would, if it goes back in, that's where you get your n to the third, this 4 divided by that 4, the n is still divided by 4 here, and that 8 is divided by 4. So it just depends on if it's beneficial to keep it as a fraction or separate out each of your terms individually. Okay. If this second example is confusing to you, go ahead and focus on this one for now, and we're going to come back to doing this more a lot throughout the year, so don't panic about that one. Okay, now what happens when we get into a little bit of a harder division problem? Harder meaning that we're now dividing by a binomial instead of dividing by just a single number. Okay, so we're going to go through and we're going to do long division. You can also do this with synthetic division, so I'm going to show you both ways. So long division, you would set this up as your dividend here. So it's not supposed to be a square root, it's just a fraction line. Yeah, fraction line, I guess you would call it. And that's supposed to be cubed, 4p squared. So when you do long division, and you do this polynomial long division, you follow the same steps. So what you're going to do is take, and you're trying to find out, you really only are going to use this first p. We're going to know how many times can p go into p cubed. Now, a way to rephrase that differently is what do you have to multiply p by so that it equals p cubed? Because we want to have the same value here to subtract out so that this cancels. So if I multiply by p squared, then I'm going to take this and I'm going to multiply by p to give me p cubed, and I'm going to write it straight underneath here. Then I'm going to multiply it by 8. So then I get plus 8p squared. Okay, so I find the value that makes this cancel, and then I multiply it by both of those values so that I have values to subtract. Okay, now we're subtracting this whole thing. So first of all, it's important to know that p cubed minus p cubed is 0. That is what our goal was. If that doesn't come out as 0, then you've done something wrong. Next, we need to take this term and subtract it. Subtract this term. So we have 8p squared minus, or 4p squared minus 8p squared, which gives us a negative 4p squared. Now we're going to start our process over, but this time we're going to pull down our next term. And this time we're going to find out what do I have to multiply p by to give me a negative 4p squared. So I need to multiply it by negative 4p. Because when I multiply these two together, it gives me the same number that is right here. And that was our goal, is to eliminate that first term. Okay. But now we need to multiply the negative 4p by this value as well. So we get negative 32p. And then we go through and subtract. Negative 4 minus a negative 4 gives us 0. That was our goal. Negative 22 minus a negative 32. So if we have, that's really essentially the same thing as a negative 22 plus a 32, right? So that gives us a positive 10. So we have now positive 10p. We bring down our next term, which is the 74. And we're back to the same process. What do I have to multiply p by to get it to equal 10p? Well, really, it's just a 10, because p times 10 is 10p. We're going to be subtracting those. And now we multiply the 10 by the 8 to give us 80. And then we subtract. 10p minus 10p is 0. 74 minus 80 is a negative 6. Okay, so now in this situation now, this means that we have negative 6 that is the remainder. So you hear it's called the remainder. Now in polynomials, you don't just want to write remainder negative 6. What we want to do is we want to take negative 6, and what it means is that that's a remainder because it has not been divided by this polynomial yet. So we're going to take it and write it as p, 6 divided by p plus 8. Okay, so hopefully you've done that process before. I did take the time to go through it to make sure it's here, but let me know if you have never done that before, if you need more examples, we can do that. Okay, now synthetic division. Synthetic division only works if what you're dividing by has a coefficient of 1 and a power of 1, and it's a term just like this. So it has to be a variable plus or minus a number. If you have that, you can do synthetic division. And just a reminder of how to do that is you're going to take and put the number in a box up here. Let's write this all out real quick. So where this term comes from is if you have x minus this number n, the value that goes in here is your n. So if you look at this, because we have p plus 8, we're going to look at it as x plus 8. Because this is a minus n term, this has to be the opposite sign. So we can talk more about that as well. That's kind of something I'll go over a lot more in pre-calculus than in calculus to hopefully kind of have an understanding. Because the format of this is x minus n, when this, you have to change the sign of what it says in the factor. So if it's x plus 8, you would put negative 8. If it says x minus 8, you put positive 8. Okay, now we take the coefficients of each of these numbers. So I'm going to take each of the numbers, and I'm going to take just the coefficient. So this one has a coefficient of 1. This has a coefficient of 4. This is negative 22 and 74. Okay. Now, you always pull down your first term, and then you use that to multiply these. So we're going to take negative 8 times 1, which gives me negative 8, and then you add these two terms together. So the two terms, you add them to give you negative 4, and then we multiply this by this number to get what goes here. Negative 8 times negative 4 is a positive 32, and you add these two terms together to give you 10. Multiply those two to give us negative 80, and then add them together to give us negative 6. Now notice that these numbers are the same leading coefficients that we have in our answer here. Because this, you take the next power down, so this is p cubed. This is the coefficient for your next power down. So we'd say the answer would be p squared minus 4p plus 10. And then we know that because there's another term, that this is the remainder. So we would do 6 divided by p plus 8. Okay, different way to do the same thing. It is important when you're doing both of these, you have to have a term for each one. So p cubed, p squared, p x cubed, x squared, x. You have to go down the line. If there's a missing term, you place a 0 as a placeholder. Okay. Okay, so there's a quick review of the synthetic and long division. You can do whichever one you're more comfortable with. Okay, let's look at solving a system of equations now. We're going to do 2 more quick examples. I'm going to try and keep them short. If you're trying to solve a system of equations, what you're trying to do is to find where 2 lines cross each other. So you want to know where their x and y values are the same. So if I have 9x plus 36 equals 15y, and I have 8 equals 15y plus 2x, and I want you to solve using elimination. So what elimination is, and hopefully you guys remember this too, this should be a review is why I can kind of go fast on this. So just remember, if it's not a review, you need to come talk to me and we'll get you more detailed information. So if you're solving by elimination, remember that this is where you have to write the terms in the same order. So I'm going to take 9x, and actually you could probably move these around. I would move it over, so it's negative 15y. Getting this 15y on the other side, and I would move my 36 over. That's just because I like to have it in the standard form, just because it's easier to see what's going on here. So then I would have my 2x plus 15y I would write on this side. And remember, you're following all the rules of algebra, making sure that you're not changing any signs or values of these without following the rules of algebra. Okay, so if it moves from yeah, if you're moving just one term over, it should be changing, like you'd have to subtract the 15y. I didn't change the sign of these because I didn't move them over, I just flopped these two sides. So I rewrote it exactly the same as where it is, I just flipped it to the other side so that they would line up. Okay, now with elimination, what you're trying to do is eliminate one of the variables. So here I can eliminate my y's because they're both the same if I add these two together. So I'm going to go through and I'm going to add the terms together. So I have negative 9 plus 2 gives me a negative 7x. And then I have negative 15 plus 15 gives me 0. So that gave me a 0y, which 0y is just 0. So that one is gone. Negative 36 plus 8 would give me a negative 28. And then I can go through and I can solve for x. So to solve for x here, I divide both sides by negative 7. And I get that x equals a positive 4. Okay, so I just solved half of the problem because I know now that x equals 4. Now we still need to know what y equals, but we have an x variable that we can plug into either one of these equations. So I'm going to take it and choose one of the equations and plug it in. So I'm going to take 8 equals 15y plus 2 times 4. Okay, I'm going to substitute in the x for that 4 right there. Or the 4 for the x, I guess would be the correct way to say it. Okay, which means plus 8, which if you look at what happens, now we subtract 8 from both sides because we're trying to solve for the y. And I get 0 equals 15y. I want to get y by itself, so I divide by 15. And what is 0 divided by 15? 0. So we get y equals 0. So our solution that we are looking for is a coordinate point that they share the same value. They share the same value at the coordinate point for 0. Okay, so that would be where they share that same thing. So that's using elimination to solve a system of equations. Okay, now how do we use substitution? Do you remember using substitution? So for substitution, it's the same thing that you're doing, it's just a different process. And I am fine if you prefer one method over the other. I do not mind if you do the method that you prefer. It's good to learn both, and you should have at this point in your algebra career learned how to do both. But I'm going to tell you now that as you go into higher math, that you can choose which way you do it. And one may be easier than the other in a specific problem, but you still have that power to choose which way you want to do it. So if I want to choose now, I'm going to do substitution on this one. I personally prefer substitution, and that's just my personal preference. So what I do with substitution is you take one of your equations and you're going to solve for the variable. So for instance, I'm going to take this and I'm going to add 3y to both sides. So I get that x equals 5 plus 3y. Now I'm going to take this x that I found right here and I'm going to substitute it in, hence the name substitution. I'm going to substitute it into the other equation in place of x. So I get negative 3. Instead of timesing it by x, I'm going to times it by 5 plus 3y. And then I'm going to write the rest of the equation. Minus 3y equals negative 15. Okay, multiply it in, I get negative 15. Minus 9y, because I multiplied the negative 3 to both, minus 3y equals negative 15. I'm going to do this algebra part a little bit faster, so not so much time for you guys to watch me doing math, because I want you to be doing it. We got to get you guys doing the work yourself. This should just be a reminder. I'm going to add 15 to both sides, which gives me negative 12y equals 0. And in this case, y then would equal 0. Now, once you have your y value, you can substitute that back into either equation to find what the x is. So x minus 3 times 0 equals 5, which means that you'd get 3 minus 0 equals 5. So x minus 3 times 0, which is x minus 0 equals 5, so x equals 5. So this one, the solution then would be the coordinate point 5, 0. Remember, your x comes first and then your y. So this means on the coordinate plane at the point 5, 0, these two equations cross each other's paths. Okay, that's a 24-minute video. Sorry it's a little bit longer, but hopefully it's a quick review of a lot of the polynomial stuff that we'll do.